So basically, we're looking at the ECG of a PVC. So what do we mean by the term PVC? PVC stands for premature ventricular contraction. And the name is pretty self-explanatory. What do we mean by premature? Something that happens before it is expected. This is also known as an extra-systole or an ectopic beat. It's because we have a ventricular contraction happen before the expected time for the next ventricular contraction. So if you look at this ECG, you can see a lot of QRS complexes. If you observe lead to first, you can see both normal QRS complexes and what appear to be a bit abnormal. If you were to ignore these big QRS complexes and just notice the small ones, you can see that the time interval between them is normal. It is constant because these are the normal beats that were caused by the normal impulse coming from the sinoatrial node. But what about these big ones? Now these big ones, they are not because of the sun. They're because of some ectopic focus that is developed somewhere in the ventricular muscle mass that is discharging, right? So the question is, why the biggest size? Normally the QRS complex doesn't have this big of a size because depolarization of both the ventricles is happening at the same time, and the depolarizing vectors of both sides are basically opposite in polarity, so most of that cancels out. But over here, because of the way the ectopic focus is made, the direction of depolarization is generally just one, so there isn't any sort of cancelling out, so we have a bigger one. Also, if you compare the duration of this with this one is definitely prolonged, because while these impulses traveled through the Purkinje system, these traveled through the muscular mass where they originated. They cannot propagate via the Purkinje system, so the conduction is much slower. That's another thing to do with PVCs because of where they originate. The fact that they are made up of ectopic foci, it is a high voltage. Now when you observe this and then you observe this, then you have a normal one again, and then you have an abnormal one. So this is the normal one with the normal P, the normal QRS, the normal T. Over here for the abnormal one, we don't have any P. There isn't any need for it because that impulse doesn't simply pass into the atria. It cannot. We have a T wave, but it is inverted. So is T wave inversion a bit of a characteristic feature? It is not. Simply the polarity of the T wave will be the opposite of the extra-systole. That is it. Now these are generally benign because they might be if you take too much caffeine, you ingest a bit more alcohol than you're used to. Even athletes can sometimes have these, or if even during emotional irritation you can have these. However, these can be of a bit of concern because sometimes these are because of the re-entrant impulses that are originating around the borders of, there was some infarction, and the part of the normal impulse kind of divided at that point, and that divided impulse eventually traveled all the way over whatever and caused this contraction to happen before normal. Now this is a bit of similar thing to what happens in circulatory circuit movements in fibrillation, except the impulses, there's development of far more ischemia first, so the waves divide far more before spreading all over, and more refractory areas develop. So it's the same thing, just made worse by circumstance. So people who have too many PVCs, they're at a high risk of developing ventricular fibrillation, and this is especially true when PVCs occur during the vulnerable period for causing fibrillation, just at the end of the T wave when the ventricles are coming out of refractoriness. Because if that point there is this kind of a re-entrant way impulse, a PVC, some PVC happens when it shouldn't. Part of the area is refracted, part of it is not. This impulse touches an area of refractoriness, divides into two. Then another area of refractoriness is reached because of the random propagationary direction. They also So that is how a fibrillation might have been caused.